Welcome to EDU World Space.
For this exercise, we are given a random sample of 200 commute times in the US, and the sample average was 27.5 minutes, and the sample standard deviation was 18.9 minutes. And we were asked to test at a significance level of 5% whether the mean commute time is less than half an hour. So that means that our null hypothesis is that the mean commute time is at least half an hour, or 30 minutes. And the alternative hypothesis is that the mean commute time is less than 30 minutes. Now, one other thing that we are told in this question is that the commute times in the US are heavily skewed to the right. However, we have a large sample, and therefore the central limit theory comes into play, which tells us that sample averages for samples of size 200 will be approximately normally distributed. And so our test statistic is given by this formula. It's the sample average minus the null hypothesized mean divided by the sample standard deviation over the square root of the sample size. And this is equal to 27.5 minus 30 divided by 18.9 over the square root of 200. And this comes out to approximately minus 1.871. So now we have to find the p-value associated with this test statistic. And we note that our alternative hypothesis is a less than hypothesis, or a left-tailed hypothesis. And this tells us, for a left-tailed or lower-tailed test, that the p-value is equal to the probability of having gotten a test statistic at least as low as the one that we got. And here, this is the t-distribution with n-1 degrees of freedom, or 199 degrees of freedom. And this comes out to approximately 0.0314. So this is the p-value, which is the answer to this question. And also comparing that to our significance level, p-value is smaller than the significance level, so therefore we reject the null hypothesis, which means that we can conclude that there is evidence that the mean commute time in the US is less than half an hour.